So our goal for today is to get through, I think it's 6 presentations, and we've got them already queued up and ready to go. So this is the first group here. I think it's, so let me get my timer ready.
Okay.
Okay.
Yeah, so we're talking about how AI affects biases. And one question that comes up during this is, how do we define fair when it comes to bias? So we conducted a literature review and interviewed some experts on the topic. Professor Muhammad Samani, Professor and Assistant Professor Douglas Gilbo. We spoke to all of them. So the first thing we're going to do is define what bias is. So the kind of traditional idea in psychology is prejudice in favor of one group over another. However, our research has brought up the question, does fairness mean zero bias? So there are many definitions in AI literature on how to define fairness. One example we came that kind of is an example that makes us question whether zero bias really is the correct fair choice in all cases is predicting maternal mortality rates. So there are algorithms that predict how likely a woman is to die during childbirth, and they have found bias in predicting that Black women with the same characteristics as white women are more likely to die in childbirth. However, it is true that the rates for Black women that die in childbirth are higher than for white women. This is a real world problem. Our biased algorithms may actually direct resources towards Black women over white women during childbirth that might help balance this increased risk, which may be a good thing. So it kind of adds some questions about how to define fairness.
Yeah, now speaking of bias, it can arise at any point during training an algorithm, but a huge source of bias is in our data sets. We learned that even really enormous data sets can just skew towards socially dominant group views, and it can actually overrepresent things like racism and misogyny compared to even the real population. And as you can imagine, this can have really bad downstream effects, especially because tools like ChatGPT are trained on these data sets.
So conducting our interviews, we kind of had two themes. One was that there are a bunch of kind of real benefits to AI in situations dealing with bias. The other one is that there are some really serious implementation challenges in it. So the first one is on measurable bias. So humans, if you can't peel open a human's brain and discover what their biases are, but you can with an algorithm. You can measure whether or not it's biased. And because of that, there are a number of technical solutions you can apply. In a similar way, you can't rewire someone's brain who's racist to make them non-biased. There are kind of increasing numbers of methods in the literature of how to fix this. So this is really promising.
So we find ourselves in this really interesting situation where there are some technical ways to mitigate harmful biases, but we also learned that our current infrastructure and political climate really disincentivizes pursuing these. So for example, some of you might have heard on the quote unquote big beautiful bill, there was a proposed 10-year ban on all AI regulation. And luckily this was struck down, but it sort of illustrates the imbalanced incentives right now. And we also learned that some of our existing infrastructure, such as the legal infrastructure, is not perhaps well suited to regulating AI. We learned from one of our professors that the legal definition of bias actually involves intent, which is very difficult to prove for an algorithm compared. So in summary, in reflecting on some of our original research questions, we learned that defining fairness in a single best catch-all way is fairly intractable, but there are so many situations where you can find specific definitions of fairness tailored to the values and needs of the people. And similarly, bias is not always negative. It is very context dependent. And then lastly, some personal takeaways we had are that biases in AI are perhaps in some ways easier to fix than in humans, but this is balanced with like a very real practical implementation challenge due to our infrastructure and various societal issues. So we find that AI provides a sort of distorted and amplified reflection of social problems that are not entirely new to us. So that is our presentation. Thank you guys so much. Hope you enjoyed.
Don't close the laptop.
All right.
Very good. Since we actually have fewer presentation stages, anybody want to ask a question while I get the next one set up? I already asked you my question. Any of you folks have a question?
ChatGPT, the transparent tool, at 4.5 out of 5 for trust, while Grammarly scored 3.2. In terms of satisfaction, users reported feeling about 30% more confident when they could see explanations.
However, the transparent tool was slower, about 10 to 15 seconds longer to use per prompt. And several participants said transparency made the AI feel more human and collaborative. One of them even said it felt like the AI cared about how I think, not just what I write. There were also some surprises. A few users still trusted the Apache AI more, especially when it seemed faster or more confident. And transparency helped most for creative or ambitious tasks, but less for straightforward grammar checks.
We also noticed people anthropomorphize the AI, describing it as helpful, judgmental, or thoughtful. There were limits to our study. The sample size was small, 8 participants, and our trust scale was pretty subjective. Some participants even misunderstood explanations as justifications rather than reasoning. As one of them put it, even a perfect explanation can't replace intuition. And overall, we found that transparency generally builds trust and satisfaction. But users also care about speed and clarity, so transparency might need to be optional or adaptive, not forced on everyone.
For human-centered AI, this means designers should make sure systems explain why they act, not just what they do. And for next steps, we would like to expand our study to a larger group and test different levels of explanation in areas like education and healthcare. Thank you so much for your attention.
Okay, hi guys. Our names are Sean and Emma, and today we're going to be talking about driverless in a human-centered world. So our guiding question for this project was how AV engineers, researchers, and designers create trust and human comfort in the driverless ride experience. And I'm sure a lot of us have been in Waymos or self-driving cars before and know that it's a pretty different experience from what we're used to on the day-to-day. So we wanted to understand how industry experts are bridging that gap. For this presentation, we'll take you through our entire process from the motivation behind the project to the methods to conduct our research, the findings from that research, and ultimately the relevance of this project and why it matters.
So starting with our motivation, we were inspired by the talk given by Andrew Chatwin here in class from Waymo, who emphasized that autonomous systems need to be human-centered by design, And so that raised the question for us, what does human-centered engineering actually look like in practice? And how do AV companies build trust with riders? And so that curiosity is what launched this project.
Key methods for conducting our research. The first was a literature review. So we read up on 3 leading companies in the AV space, Waymo, Neuro, and Zoox specifically, and we tried to understand their mission, their history, and how they use human-centered design in their work. We also conducted field research. So we went on a couple of observational ride-alongs in Waymo vehicles, and we looked at everything from the pickup experience, so how to unlock the doors, ride, to the actual driving of the vehicle itself, and finally to the drop-off process and how the car signaled that we were ready to get off. Lastly, we conducted 3 interviews with industry experts. They all requested to remain anonymous, but we have their interviews in our final video. And we talked to a human factors researcher at Zoox, a user experience researcher at Zoox, and a user experience researcher at Waymo. And all of them had really, really interesting insights. And the interview questions were based off of experiences in the ride-alongs.
So our findings from these interviews were threefold. First, our interviewers showed us that human-centered design acts as a prerequisite for safety and usability. One researcher in particular told us that design without research is art. And we found that to be a really interesting sentiment, as it emphasized that every decision must be grounded in user data. And this interviewee also meant teams actively gather insights to help product managers, software engineers, and designers understand what actually matters to people during a ride, and that informs a lot of the design choices in these vehicles. Second, another takeaway was that trust must be designed, not assumed. So we learned that trust is shaped first and foremost by how the vehicle drives. Is it predictable? How smooth is it? And as one researcher joked, is it boringly safe? An industry goal is that you want people to forget that they're even in a driverless car. Another interviewer brought up a really interesting point that people tend to anthropomorphize complex technological systems. So the car needs to behave in ways that match riders' mental models. One example that Andrew brought up in class and we also observed was the center console screen in the backseat of Waymos that show the projection of the decision making that the car is going through as it's driving through the roads, show pedestrians and other vehicles like a human would. And finally, trust isn't one size fits all. AV engineers measure trust relative to rider cohorts, so pioneers, mainstream users, and suspicious riders. And the goal isn't to convert skeptics into early adopters, but rather to understand whether technology increases within each group's baseline.
So why does this all matter? We think that our research has relevance on 3 different levels. First is the industry level. So human-centered design directly affects the adoption of these new technologies. If we have trustworthy and predictable rides, then it helps AV companies scale safely and sustainably so that they can give back even more time to more people. Second of all, on the societal level, AVs have the potential to increase accessibility, give us safer rides, safer roads, less traffic, and more affordable mobility options. But this is only the case if people actually feel comfortable using them. And third, on the ethical level, designing for trust is ultimately designing for human well-being. So emotional safety, transparency, and respecting user mental models is incredibly essential if AVs are going to coexist meaningfully with human riders in the future.
So in short, designing a driverless experience is just as much a human challenge as it is a technical one. And thank you all for listening. If you have any questions, these are emails. Final video that goes more into depth in our interviews.
Perfect. All right. So we have time for a question or two. Go ahead. I'll switch the thing you over there. You're the next thing?
Yeah.
Come on. Okay.
All right. Hi, my name is Mihaela. My name is Fisher, and today we're going to be answering the question, can AI do science? So before I proceed to the next slide, I want you guys to think in your head, what is the first thing that pops in your head when I say AI scientist? And basically what we're trying to do is get to your mental model of the thing we're studying today. So it may have been something like this, a robotic arm in a lab using a pipette. But for today's sake, we're going to use this operant definition of AI scientist of software. It's a collection of software that a human uses. There is a human in the loop here. We're not yet at the point currently where AI scientist means somebody you just kind of set aside in a lab and let them run and you don't check up on. So that's important to start with because our research question is, can an AI scientist under this operant definition actually run a real machine learning project from end to end? And in order to do that, we're looking at Sakana's AI Scientist version 2 that Mihailo is going to explain now.
So Sakana AI is a Japanese startup that produced this language model agents pipeline that takes in the whole ML code base and runs the project like end to end, basically. It brings from ideas, it rewrites code, it runs experiments, generates plots, and eventually writes a full paper in LaTeX. And they even have an automated reviewer who scores the papers based on the conference criteria. And the version 2 actually got a particular attention recently because it was the first paper fully automated by AI to get accepted to iClear 2025 workshop. And basically, Sakana claims that you can get a paper in, like from $15 to $20 based on the what language model you're using. And so we wanted to see like what does it actually look like in practice. So this is actually how it looks like when you run it. So step 1, you create a content environment. That is actually the part that took the most time, just setting up all the environments correctly. And step 2 is actually you run the ideation script. You provide an markdown file with your general idea, and then it takes that, it creates 10 to 20 ideas. Actually, I think 20 is the maximum you can get. And we pick the idea about the measuring overconfidence in language models. Basically, LLMs are like hypothesis that LLMs are poorly calibrated to a probabilistic reasoning task, and that adding reasoning scaffolds may help. And step 3 was the main actually event where you pass this JSON file with the ideas that was created by the ideation phase, and then it runs all the experiments, generates plots, and eventually writes a paper. And one choice we made actually is that we use the O1 reasoning model instead of Claude, which is a mistake that we thought we were gonna do better science, but it was a mistake. We'll talk about it. And before basically we go into what the Sakana produced, it's not all that easy. It was a really debugging challenge. So CUDA version mismatches, dependency errors, and the tree search explored 14 different experiments nodes before, and it failed on all of them in our first run. So we actually had to rerun it. And on top of that, we burned $30 of the API credits because we use O1 model, and it generates much more tokens than the other OpenAI models. So we had to shut it down actually in the middle. And obviously this isn't a polished result. It's a research software. You should expect debugging and also expect surprises with cost. So this is kind of what he actually produced. So the very surprising thing, you can write PyTorch code. He compiled it okay in the second run. It creates synthetic data, and it even produced plots in the end. And it even found the batch size of 64 with a learning rate of 0.05 gave the best results when it comes to Brier score. And if you show me this output, I could believe that an undergrad or a grad student would have made it, and the code worked, the hypothesis was plausible, and the question is whether running experiments is the same as doing science, basically.
Yeah, so basically where we're at right now is on the lower end of the spectrum of AI science. We have a large berth of other companies kind of getting into the game. We have Google's AI co-scientist. We have Carnegie Mellon's co-scientist that actually is in the lab attached to tools, moving and manipulating things around. Stanford has its own virtual lab that helps produce 92 COVID nanobodies that perform better than what was currently available to the world. So we are starting out here. What Mihailo and I had access to was very much the lower end of the spectrum, but the scale is only going to continue to increase, which makes you ask, what's next? I don't think my job is in threat as a football player. Mihailo's might be as a computer scientist. We don't know. That's something we discussed. Thank you for listening.
Go for it. All right. Hi, I'm Chapman. Thank you for coming to our presentation. Today we're going to be talking about something many of us do every day, which is prompt engineering. So when we set out to come up with the topic for our, we thought about what misconceptions do we have about the AI and the time we already spend. One thing we spend a lot of time on is prompt engineering, and we asked ourselves, how useful is all this time we spend prompt engineering? Is it actually a reliable difference maker that it improves our results and our interactions with AI and LLMs? Or is it sort of just placebo? And so Constantinos will explain how we examine this question.
Hi guys, so the methodology that we went with was to ask 4 Stanford undergraduate students to talk to ChatGPT for 3 minutes, and we used 3 different prompts that they did not know, making sure to test whether our prompt engineering will be forecasted by the students who are being interviewed. So in the first prompt that we put to ChatGPT, we said that it should discuss with our undergraduate students their career stressors or some kind of uncertainty within 3 minutes, and we told it to have no prompt, and then we told it to have a blunt and emotional tone, and then we told it to have a warm and empathetic one. And Yash is going to tell us about the results of our findings.
Yeah, hi everyone. So we benchmarked a set of metrics quantitatively and qualitatively. To our surprise, the participants were actually really accurate in evaluating personality. So on the default one, they got it right all the time. And for the empathetic and logical one, 3/4 of the time. But the confidence scores were a different story. They had low confidence in their actual ratings. And we found that, for example, one participant found the empathetic personality to actually be quite logical in its tone. And they, on the whole, noted mostly stylistic things like emojis used and actual like content changes with the personality.
Okay, so I hope everyone can still hear me. I'm going to talk about our key takeaways. First, participants could identify which personality they were talking to. They got 10 out of 12 correct. However, they weren't confident. People doubted their guesses, and several changed their minds once they saw all 3 responses side by side. And third, the prompts were easiest to spot in hindsight. Participants relied on surface cues like bullet points, structure, and length, which carried most of the personality signal. Big picture, prompt engineering did change how ChatGPT sounded, not how it reasoned. The logical prompt didn't make the answers more rigorous, it just produced more formal structure. And the emotional prompt didn't change the substance either, it just added warmth and encouragement. So users weren't judging reasoning quality, they were reacting to style and tone, which is why they could identify personalities but still felt unsure. So the major takeaway is that prompting shifts the presentation, but not the underlying thinking.
Yeah, so what does this mean beyond our project? People can often base ChatGPT's credibility or AI's credibility based off style often, especially in areas like tutoring or mental health or financial advice. We often use words sort of as signals. And so further, we want to examine how these different styles actually affect people's behavior, and then also do more prompt engineering with more detail and lengthier prompts to see if there is a way that we can actually improve the actual results and the actual content. But for now, with simple prompt engineering, seem to only change this. Thank you for coming.
Thank you.
You guys win the award for having the most time left. Any questions?
There could be lots of different types of prompts, and you measured 3 in one particular direction. You're going to do a follow-up. What other types of prompts would you want to measure? Are there kinds that you think would make more sense?
Yeah, so I'd say for this one specifically, we focus on more personality-oriented prompts and ask them to like go through sort of a discussion on a career advice or something in their life. But I think in the future we want to get more into like specific tasks, like writing an essay, let's say, or like doing math, and see if I give you a prompt that's like optimized for writing an essay, and then I give you math homework. is it hard to do math on it? If I write a prompt that should be better than math on it. So we'd be more interested in how the results are not actual task-oriented things rather than just conversation.
I think one also takeaway is that in reality, the reason why style was changing is because ChatGPT as an LLM, its job is to predict the next most probable word that will go in the sequence. So in reality, the style changes with this emoji deviation because it is predicting the next word at the end of the day. So the prompt can do as much at this point.
And, sure you said it, but how long were your prompts that you gave?
If you see here, this was the prompt that we.
Okay,
these
so
were the
there's no
three
problem
prompts.
in those two. So they're fairly short. I've seen prompts that are like 500 words long.
Yeah.
So if you think about testing longer ones, as a way of long versus short.
We found that like this was pretty simple and just trying to describe these exact same things. But I suppose like on the task-oriented stuff, like I was saying, like more details is helpful. But in terms of just like a pure personality, decided to keep it simple. Right. Another question would be like if reinforcement can also help too, like one prompt at the beginning and then 2 prompts later saying it again. Like I'm asking you again to do this and see if that improves.
Lots more work to do.
Yeah.
Great. Thank you very much. Thank you. Thank you. Go. Generation shifts.
Awesome. Well, my name is Michael and this is Mena, and today we'll be talking to you about how AI recommendation are trusted across generations and how labeling and writing style influences that trust. So moving on into our initial thoughts. Well, AI is increasingly shaping everyday decisions, and a lot of research shows that trust in AI depends on mental models, transparency, explanation style, and familiarity with automation. But what's missing is how generations respond to AI recommendations in everyday scenarios, like movies, books, and products. And since younger people have grown up with the AI normalized environment, and older adults have seen multiple waves of automation distrust, we wanted to test whether those generational differences actually show up in real decisions. Now, some literary review we took from these 3 papers, Green and Chen, Milkamp, and Dodge. For the sake of time, I won't mention all of them, but the most important we found is actually that trust is malleable and influenced by present and not just accuracy. And this brings us into our research question, which is how does trust in AI versus human recommendations differ across generations?
Now, before we get into our actual findings, I want to talk a bit about our methods and how we found our data. So we surveyed from a total of 59 individuals from the Palo Alto region, ranging from individuals under 18 to 40 and up. We had a good range, but mainly set around 18 to 24-year-olds, as that's our age group, and then followed with 40 plus, just to make sure that we could really see those generational differences. In terms of methods, we first created an anonymous survey, then we had in-person interviews, and then on top of that, we cross-referenced with past literature from in-class as well as outside. In terms of the survey design, we really had 2 main methods of which we wanted to set this up. First, with label and context. So what we posed in this question was first giving them a label of who recommended them things in their scenario and some background information. But this did not include the output. So our main motive here was really to see how label really changes how people trust their recommendations. Along with that, we also wanted to see label and tone. So really, how does framing, as we saw in the paper, change how people trust who to trust across these generations. So what this really looked like is having a label saying this is recommended by a book YouTuber or by an AI system. And then our output is either from an LLM itself or it's from that human reviewer. However, we really wanted to see if they really care about tone or just label. So we had mismatched actual scenarios in which we had a human reviewer, but then the LLM output or vice versa. This really let us know if they were really looking at the label or their actual tone and output. Now, along with that, we wanted to state that all of our LLM outputs as well as human reviews were from actual reviewers. So either sourcing from Goodreads, YouTube recommendations, or online Best Buy reviews, or also sourcing from the actual LLM chatbots such as ChatGPT or Claude. Along with that, we also wanted to test different tasks because we understand that with subjective things, maybe they rely more on people or AI, and also data-driven choices or big medical decisions. Along with that, in terms of our interview design, we had a similar model where we had recommendation pairs, but this time it was done more in person to see, does having a human there change who they choose to trust? And along with that, get a bit more background on why they made that decision. We really want to highlight some of the quotes that we saw, specifically 18 to 24-year-olds, where they stated that, "I think AI will put together an objective opinion of what everyone said." And we thought this was super interesting because they like this hybrid approach of first having the AI summarize it, but summarizing actual human reviews or human responses, and that's what they trust. Versus 40-year-older who many times mentioned, "I trust a human over an algorithm that I have no control over." So it seems like they really value transparency. You can also check this out on our Google Sheets. In terms of results, there's a lot of breakdown, and we did a bit of data analysis here to see really what this means. But I really want to highlight one thing, which is trust versus tone, because I thought this was super surprising. In individuals who are younger than 24, most of the individuals actually favored tone over label. So many times they didn't care what the label actually said. Instead, they cared more about what the output was. Versus 40 or older, only 19.4% cared about tone, and the rest of them chose based as a label. So even if it was an AI response or AI label with a LLM response, they still chose that human response. So that was super interesting.
Now, what are the implications of this research study? Well, just to reframe what Mena said, trust in AI is not universal. The younger users are influenced by tone, personalization, and warmth, while the older users are influenced by source labels, perceived expertise, and transparency. Explanation framing also alters trust. Younger users benefited from the reliable, human-like language, while older adults need explicit reasoning and credentials. And this supports the prior research from Dodge on how framing influences trust. On to future researching possibilities. We need to acknowledge the room for improvement within our study. This study was conducted within a relatively advanced environment in Palo Alto with Stanford students as well as education or people that have gone through higher education, which is not necessarily representative of the country as a whole. Also, cross-cultural trust differences. From a paper, Artificial Intelligence and the Generational Divide, it states how American individuals value transparency more than Europeans, which means that there's just a difference in trust and transparency across different cultures in different countries to account. And then finally, for future research in high-stakes contexts like medical or financial systems would be interesting places to branch out into. Finally, for our conclusion, different generations use different trust strategies when interpreting AI systems. For designers, this means that AI systems shouldn't use a one-size-fits-all explanations, but instead, recommendation platforms may need age-aware or adaptive explanation styles to ensure trust is appropriately calibrated. Human citations.
Perfect. Anything you want to say, Peter? The end? Words of wisdom, conclusions? Come on up if you do.
You can have another ask me anything if you want. First of all, thank everybody for being here. It's been an enjoyable quarter for me. I think it's been an exciting time. We've been doing this for years, but it does feel like this time things are moving faster. Right? I mean, ever since ChatGPT came out, it felt like, oh, okay, AI is back in style. It does feel like this year it's really starting to hit the mainstream. So it's an exciting time, and it's been great to live through that time with you, and we'll see how it continues.
Exciting is one word. Chaotic is another word.
Yeah.
But it's definitely moving quickly because assignments that we gave this quarter were impossible to do last time we taught this class. Just crazy hard. And now it's like that one cartoon you showed about doing the problem, identifying the bird, and now it's 30 seconds of 1 minute of code. So things really have changed, not just in terms of the technical underpinnings, but I think also in terms of, like we saw from the presentations today, the expectations we have. So older people, younger people, everybody's using this stuff. How are they using it? I think this is a fascinating area.
And, you know, last year, driving cars were just kind of hypothetical. And this year, most of you have been in a Waymo, and by next year, it'll just be old-fashioned technology.
Next year, you'll be able to go to the airport. On the freeway, yeah. I tried to go to San Jose Airport. It said it'd take an hour and a half. This is going down Central Expressways. But I think this is an indication of really interesting rate of change. Because we both remember when speech recognition was always in the future. Now it's just an API call, right? Doing so something like whisper flow or doing really high quality text to speech. We've seen that in the self-driving cars, et cetera, et cetera, et cetera, just become very, very quickly piece of our everyday technical life. So I'm really looking forward to the next time we teach this course. It's going to be 100% different. Yeah. My prediction. Right. All right. Nice. Thank you. Thank you. And goodbye to everybody in video land. We'll hang up now. I know you didn't hear it because this is another piece of AI. People who are on the video did not hear you applaud because the video has a clapping filter. It takes out that extraneous noise and it zeroes the signal for them. So they didn't hear you clap. But that's why you have to go to the chat stream and quit.
Yeah, you guys, it was incredible.
It was amazing. Yes. Anyway, thank you so much. We finish off the cookies. Where are they now? Okay, there's one thing here. If you showed up late and you want some cookies, please take them. Take them. All right, thanks everybody. Also, we just sent out a message reminder, or Tobias sent out a reminder to do the survey. So when you get a chance, please do the survey. It really helps us. It helps the school determine whether or not they should invite us back again. Not to bias you, but we've gotten really good scores in the past. All right, we'll see you all later.